Welcome to qnawire.
Let's draw the force diagram for the water. So if this dot represents the water inside the bucket, then we have a normal force pushing down, which is the bucket pushing the water. So that's the normal force. And we also have an additional force of gravity. So this is mg, and it's also pushing downward. And we have a resulting radial acceleration downward. So if we apply Newton's second law for the water in the bucket here, sum of the forces in the y direction is equal to mass times acceleration in y. By the way, I'm going to let downward be positive y in this problem. Then this implies that the normal force plus mg is equal to m times v squared over r, since v squared over r is the form for the radial acceleration. Now at the minimum speed, the normal force that the bucket puts on the water approaches zero. So this is the key idea of the problem. At min speed, n is equal to 0. If n is equal to 0, then the water will start falling out of the bucket. And so what we do is we set n to be 0, and we solve for the speed that's the case. And so when n is 0, we get mg is equal to v squared m over r, cancel the m's, solve for v, and you get the square root of g times r. Plugging in the r they give us, and g being 9.8, I get 2.42 meters per second. And that's the final answer.